All right, 1.7 day 2 kind of extends on from what we covered in that first section where we do absolute values with equal signs. This is absolute value inequalities. So in absolute value inequalities, we write as a compound inequality as an and or an or statement. And we use the symbol to decide which statement it is. So if it is a greater than or greater than or equal to sign, think of greater than as great or. We use an or symbol. If it's a less than or a less than or equal to sign, think of less than. We use an and. Okay, and that's how we know what word to pick, and that word's going to help us know what our graph is going to look like. So if you look at the first absolute value inequality, it says that ax plus b, the absolute value of ax plus b is less than or equal to c. So what that means is if you're at 0, okay, you could go c is some number, right? It could be 5, 6, 7, 8, 9, 10, could be any number. But if it's less than c units from 0, that means you can go up to c units to the right, and you can go c units to the left. So that would bring you to positive c or negative c. If you go to the right, it's positive c. If you're at 0 and you go left, it will take you to negative c. So what this inequality is saying is that you have to stay closer than c away. So you can be in the shaded green or in the shaded blue. So how we solve that algebraically is, so it's got to be between those two. We would write either ax plus b is less than c. That would be the blue shaded part. And this is a less than symbol. So you would say and, now we could say ax plus b is greater than negative c. That would be the green part. So it's either bigger than negative c and it's less than positive c. Okay, and this graph is going to be a sandwich. Okay, it's going to look like this. Okay, when we have a greater than symbol, like ax plus b, absolute value of ax plus b is greater than c, this means the distance is greater than c units away. So it's going to be greater than c units. So how we write this would be, if we're at 0, so I'll draw my graph. If c is right here, it's more than c units away. And if you go to the left and you go to the negative c, so let's say negative c is right here, you're farther away from 0 because you're greater than c units away from 0. So how you'd write that is you would say, okay, ax plus b is greater than c. And we would say the word or, because it's a greater than, ax plus b is less than negative c. So just notice what happens. I get my highlighter. See what happens right here. This. So see that we flip that to a negative c. It's the opposite. And notice that the symbol flips. Okay, that's what happens when you make the two inequalities. The second one is always the opposite, and you flip the sign. Okay, and the last thing you do is then you solve the inequalities. And we have a couple examples down here. Okay, so the first one says to rewrite the absolute value inequality as a compound inequality. So, number 3. This is a, let me draw an arrow. Absolute value of 3x minus 5 is greater than or equal to, so this is going to be a great or. So we use or. So the first one is get rid of the inequality or the absolute value symbol and just rewrite it. Then we use the word or, because it's a great OR then. Everything is the same except for now, 3x minus 5. You flip your symbol and you change it to negative 6. So notice we flip the symbol and we change it to a negative 6. Okay, and this is going to be the compound inequality. In number 2, if it says absolute value of 5y plus 6 is less than 13, less than means it's an and. So when we write this, it's 5y plus 6 is less than 13, and 5y plus 6. We're going to flip our symbol to greater than, and we're going to change this to negative 13. So again, they're almost the same, except for, notice, you flip the symbol, and it becomes a negative 13. It's the opposite. Okay, and then we'll do 3 and 4 quickly. They're the same problem. So again, we have a less than or equal to sign. Absolute value is less than or equal to 9. This is an and. So x plus 5 is less than or equal to 9. And x plus 5 is greater than or equal to negative 9. So again, we flip the symbol. The symbol got flipped, and the 9 became negative 9. Okay, and then the last one, absolute value of 2x minus 5 is greater than 6. Greater than is an or, so it'd be 2x minus 5 is greater than 6, or 2x minus 5. Flip your symbol to less than, and it becomes negative 6. Again, flip the symbol, and it became negative 6. So that's the first step in graphing these and solving these. And then we have 2 examples of solving and then graphing. So if we're going to solve and graph these now, we have to do what we just did, rewrite them, and then solve it. So in number 1, this is a less than, so it's an and. Okay, and I'm going to zoom in. So we'd rewrite this as x plus 4 is less than 7, and x plus 4 is greater than negative 7. Okay, and then we solve these 2. So if we solve these, it'll be minus 4 to get x is less than 3, and minus 4 to get x is greater than negative 11. So now when we got this solved, we have to graph it. So make your number line. Put your 2 numbers on there. Okay, 3 is bigger than negative 11. So 3 goes on the right, and negative 11 goes on the left. And then we graph these. Start with x is less than 3. Less than means it's open, and where the number is smaller than 3, to the left. X is greater than negative 11, so it's open. Bigger numbers are to the right. So our graph is going to look like this. It's shaded in between, and those 2 circles are going to be open. That's a less than, that would be an and one. Okay. Number 2. This is the absolute value of 14 minus 2x is greater than or equal to. So greater than means an or. So if we write this out, greater than or equal to 6, or 14 minus 2x is less than or equal to negative 6. So you flip the symbol, make it negative, and then we solve it. So minus 14 would be negative 2x is greater than or equal to negative 8. And then do the same thing in the other equation, because your solving steps should be exactly the same. Negative 2x is less than or equal to negative 20. Okay, then we have to divide by negative 2. So what happens when you divide by a negative? This is where it gets tricky here. So now when we divide by a negative, so it's negative 2, we have to actually flip our sign again. So it's x is less than or equal to positive 4, or x is greater than or equal to positive 10. And I'm going to highlight that. Notice we flip the symbol because we divide by a negative. So divide by a negative means you flip the symbol. So our answer is x is less than or equal to 4, or x is greater than or equal to 10. So you put your numbers on here. 10 is bigger than 4. Notice each of these have an equal sign, so they're going to be filled in circles. So filled in at 10, whoops, and it is filled in at 4. Now, x is less than or equal to 4 will point to the left, and then x is greater than or equal to 10 will point to the right. So when it's an or statement, they'll point away from each other. Okay, and the next two problems are similar to these two. I want to do them. If you feel good, you can stop and move on to the homework. Okay, number 3. X plus 2 is greater than or equal to 3. Greater than means or. That's x plus 2 is less than or equal to negative 3. So if we solve it, it's just minus 2 all the way across. X is greater than or equal to 1, or x is less than or equal to negative 5. So we put the two numbers on here, negative 5 and positive 1. Right, well, that's obviously not working. So this is positive 1. So if x is greater than or equal to 1, it's filled in, and it points to the right. If x is less than or equal to negative 5, it's filled in at negative 5, and less than means it goes to the left. So that's what your graph would look like. And the very last one, this is absolute value of 2x minus 5 is less than or equal to 3. Less than, we're going to use the word and. So we rewrite this. 2x minus 5 is less than 3, and 2x minus 5 is greater than or equal to negative 3. And then we solve. First step is add 5. Two x is less than or equal to 8, and 2x is greater than or equal to 2. Then we divide by 2 to get x is less than or equal to 4, and x is greater than or equal to 1. Make your number line and put your numbers on there. 4 is bigger than 1. Okay, so the first one says x is less than or equal to 4. Less than or equal to means fill the circle in, and less than is to the left. Okay, then we have x is greater than or equal to 1. Greater than or equal to means fill the circle in. Greater than 1 means go to the right. So it's going to be all the numbers in between 4 and 1. And that's all we got today.